Alright, so we're going to be looking at chapter 27 today, which is diodes and diode applications. And we're going to go into some of our math problems here. We've already been discussing some of the various things about diodes, and I have taken already and made handouts for. Alright, so I've already taken some of these figures from the end of chapter 27 and made some handouts with them. So basically what we are looking at here today is figure 2731A, which corresponds to problem 2737 in your book. And we're going to try to solve for some of these problems. Alright, so we're going to do some calculations involving some of these circuits in chapter 27. This first circuit that we're looking at here is a half-wave rectifier, and that possibly could be a test question. So you want to know first of all how to identify this circuit, that it is a half-wave rectifier. Okay. Now there are several formulas involved in this chapter, and here you see some of those formulas. I am going to make another sheet which will not be handwritten, but for now I just want to make sure that you understand that there is a handwritten sheet of formulas that you do need to have. I will provide this for you if you for your homework and for quizzes or tests. Okay, so we see here some answers that we're seeking. The first one being Vs. And Vs basically means the voltage of the secondary. So we know the voltage of the primary side of our transformer is 120 volts. The first calculation that we have to make is the voltage of our secondary. This transformer is a step-down transformer. It's a 6-to-1 step-down ratio. So the first question is, if you have 120 volts on your primary and you need to know the amount of voltage on your secondary, what would that voltage be? Well, we have to use on your formula sheet. I have the formulas numbered, and we would be looking at formula number 15 here. Formula number 15 right here. Okay. And that formula basically states that the voltage of the secondary is equal to the number of windings of the secondary divided by the number of windings of the primary times the voltage of the primary. That sounds complicated, but it's really not. So let's do that one. So Vs is equal to, we said Ns over Np times Vp. And the Ns is 1 over 6 times Vp. Alright. I'm sorry. Times 120 volts. Okay, so on your calculator you're going to do 1 divided by 6 times 120. And this will give you an answer of 20 volts. Okay. So now we need to find the voltage secondary peak, and we remember that our formula for finding the peak voltage is the RMS voltage, which all of these are given in RMS. So it's going to be our old friend V. The peak is equal to the RMS times 1.414. So in this case, it's Vs peak is equal to Vs times 1.414, and the Vs is 20 times 1.414, and that gives us an answer of 28.28 volts. Okay, 28.28 volts. Now this video is already at 5 minutes and 24 seconds, so I can see that it will take probably 15 minutes to do one of these. Alright, the next thing we want is the V out peak. And to find the V out peak, we have to use formula number 17, which is the V out minus Vs peak minus the diode VB. Well, in this case, since we're using a silicon diode, that would be 0.7 volts. So V out is going to be our Vs peak, which we calculated to be 28.28 volts minus 0.7, and that gives us a V out peak of 27.58. 27.58. Now remember, since this is an odd numbered problem, here's the problem number that corresponds to this figure. You can refer to these answers in the back of the book. Make sure you're doing this work properly. Okay, so far we've got 3 answers. We've got 20 volts, 28, and 27. Looks like that made it even harder to read. So let's undo that. But you see where those answers are. Okay. Alright, so the next answer that we want to find is our VDC. And we look here on our formula sheet, and it shows us, it keeps automatically going to full screen. I don't want you to go to full screen. It shows us here that our that VDC is equal to the V out times 0.138 in a half wave rectifier. Okay. Now for a full wave rectifier, you're going to use a different value. But here in the half wave, we're going to use V out times 0.138. So the VDC is going to be equal to the V out, that's V out peak. Alright, so that's going to be the 27.58 times 0.318, and that's going to give us an answer for our VDC of 8.77 volts. So basically, if we put in 120 volts AC, we step it down at a 6:1 ratio. That gives us 20 volts on this side. And we have to eliminate what the diode is taking out. So that leaves, once we calculate our V peak, that leaves about a 27.58 volts. But we have to understand that now we're talking about a DC equivalent and no longer AC, since it's been rectified. So the voltage DC, which is actually going across this resistor, is 8.77 volts. Okay, and the next thing we can calculate is the current across that resistor, and we're just going to use our old friend Ohm's law in yet another form. IL, let's make him a different color. We'll get rid of that. Let's make him a different color. Alright, so since we're looking for current, it's IL. Current, L stands for the load, the resistance load. So what is the current across this load? IL is equal to our VDC that we just calculated over our RL of our load. So we plug in those numbers. We're going to have 8.77 here, and that's going to be divided by our load of 50 ohms, and that's going to give me a current of 175 milliamps. So that gives me a current of 175 milliamps. Okay, that's my IL. Now in this scenario with a half wave rectifier, basically all you're looking at is the diode being in series with the load. Well, we know that current stays the same in series, so that tells us that if we have a diode, a current across our load of 175 milliamps, then the current through our diode will also be 175 milliamps. So this is a really easy formula to deal with. It's just ID is equal to IL. So whatever we get for IL, we get the same answer for ID. So it's 175 milliamps. Okay. This is problem 2737. I'm calling it figure 2731A. Okay. So what the book does is it takes and it changes the winding number, and it gives you a different winding number. Okay, and that is problem 2738. We just did 2737 and they give you problem 2738. But in problem 2738, they changed the windings to a ratio of 2.5 to 1. And you recalculate the values. So that would be a practice problem for you to try. All right, so try this, see what you can do with the half wave rectifier.